Hi everyone and welcome to eMemory's webinar. We are honored to have our marketing manager, Joy Lee, to present a topic titled Comprehensive eNVM Solutions for Smart PMICs. Without further ado, let's begin our webinar today.
Hi everyone, welcome to eMemory's webinar today. My name is Joy Lee, and I will be introducing how our eNVM solutions optimize smart PMIC values. Here is the outline. First of all, I will briefly introduce eNVM for smart power applications. Then I will explain our comprehensive eNVM portfolio. Afterward, I will talk about high-density eNVM for smart PMICs. Finally, I will summarize my talk today. Let's go to our first topic. Here are some examples of the latest smart power applications. Traditional PMICs mainly played power converting roles in electronic devices. A significant trend in the power industry is to improve the efficiency of power conversion, which can be achieved by raising operating voltage, current, or switching frequencies. Another essential role of power management is to increase processing power in power ICs. More processing power can be used to dynamically adjust power output to save overall power consumption, detect and monitor battery and the environment status, and even identify and authenticate if the transmission are legal. This page illustrates the concept of designing a power IC or power management chipset. The idea is that the controller part played a more critical role than before, because the power ICs deal with more tasks and act more intelligently. The algorithms and many specific configurations will need to be stored in non-volatile memories, thus enable PMICs to be more accurate, secure, flexible, and efficient. Let's use battery management system as an example. Since lithium-ion batteries are used in our daily lives, especially in mobile devices and electric vehicles, battery management technologies are attracting more attention than before. The major functional blocks of a BMS system include controller, gauge, and charger. And different blocks may need eNVM to store different information. According to the information types, designers need to choose adequate eNVM specs for storage. For example, OTP and EEPROM can be used to store small amounts of information like trimming or parameters, while NTP and Flash can be used to store more complex pieces of information, like firmware code and data. From our experience, information stored in eNVM can be categorized into 4 types, as shown in this figure. Traditional PMICs mainly store trimming information to ensure accurate power outputs or ID information for the supply chain management. Smart PMICs will require higher density and endurance, since more configuration or firmware code must to be stored. Here are some evidences that echoes our previous observations of smart PMICs. We've gathered some statistics about the eNVM density in power management chips from our OTP and NTP tape-out histories. These 4+ summarized over 500 new tape-out records between 2010 to 2021. There is a clear trend indicating that power IC design houses tend to use higher density OTP or NTP as new process platform, migrating from 180nm BCD to 130nm BCD. There are still many designs that use only a few kilobits of eNVM density, but the density increases significantly when more advanced platforms are used. Therefore, it's reasonable to expect that this trend will continue as power management controllers become more complicated. As power design houses introduce more processing capabilities into their products, foundries now are moving toward more advanced BCD nodes. The recent power IC shortage and the lack of 8-inch capacities also pushes foundries to prepare for more advanced nodes or 12-inch BCD platforms. eMemory continues to work with first-tier foundries globally, and many projects are now undergoing in 90nm and 55nm BCD platforms. Both OTP and NTP have optimistic demand in the future. eMemory's progress is accelerating in foundries, as shown in this list. In addition, we are currently discussing more opportunities to cooperate with other top foundries in implementing our eNVM solutions. Next, let's take a look at eMemory's comprehensive product portfolio. Although smart PMICs require higher eNVM density and more advanced process nodes, that doesn't mean that every PMIC product is extremely complicated and multifunctional. Therefore, eNVM IP companies like eMemory must provide a broad product portfolio for our customers to choose from. This picture shows the density and endurance metrics of our OTP and NTP solutions. One thing worth to mention is we are now working on our SONOS Flash and MRAM, ReRAM products to provide higher density choices for our customers. If we compare our product selection to general eNVM usage, our eNVM products already have a wide span of endurance and density to satisfy different requests. We expect technologies like SONOS Flash and MRAM, ReRAM will further expand our ability to provide higher densities for future power management applications. Here is a brief introduction of eMemory's product lines. I will not explain the technical details here, but I want to point out our product positioning. NeoBit is the most mature and widely available OTP IP in worldwide foundries, especially in legacy nodes such as 250 nm and 180 nm. Many logic and specialty platforms like BCD processes already have NeoBit implemented. Our mass production records have proved that NeoBit is the most reliable and easy to use OTP IP in the world so far. NeoFuse, on the other hand, utilize oxide rupture mechanism to store charges. Therefore, it has a better capability for shrinking processes than floating gate technology. It is also widespread in advanced nodes from 130 nm to 6 nm. Although BCD platforms for smart PMICs may not go to 6 nm nodes, NeoFuse is still an excellent OTP solution for advanced BCD nodes like 90, 65 and 55 nm and even future 40 nm BCDs. Built upon NeoFuse technology, NeoPuff has a unique design that produces random numbers by extracting from the semiconductor process variation. These random numbers is one of the fundamental elements to form a hardware root of trust for secure operations such as authentication and encryption, which is now considered an important feature for power management controllers. For multiple-time programming products, there are three choices according to the required density. NeoEE uses the EEPROM array structure and FN tunneling mechanism for both program and erase. Therefore, it is very reliable and suitable for applications with small density and high endurance requirement. More importantly, both NeoEE and the NeoBit OTP have ISO 26262 ACLD and IEC 61508 CO3 certifications that prove they are robust enough to be used in critical automotive semiconductors. Our mid-density product, NeoNTP, is a flash-type NTP that provides higher density than NeoEE and allows smart PMICs to store more information. NeoFlash is a SONOS-type NTP technology that provides up to 4 megabit density for storing program code and algorithms. Next, I will explain our platform availability for smart PMICs. Usually, people think power management products use BCD platforms because it often requires high voltage operations. However, logic process for microcontrollers is also a popular choice for smart power applications. Using NCU with discrete power ICs on PCB board as a smart power system is also quite common. Here we list the related logic, low power, ultra low power, and even embedded flash platforms with our products. Embedded flash platforms are usually for MCU applications. They sometimes use OTP or EEPROM to store trimming and small configurations, while the flash memory is used to store high-density programs and algorithms. eMemory's products availability on logic platforms is comprehensive as well to meet all kinds of requirements in smart power applications. One of the greatest advantages of eMemory compared to our competitors is that we can customize our IPs for our customers. For smart PMICs, we have different approaches to optimize our eNVM IP performance. Besides keeping up with foundries' new generation BCD platforms for improving PowerMOS performance, we've renewed our NTP design with minimal extra masks and simplified NTP peripheral circuits for smaller cell sizes. Single power design, in other words, pure 5V BCD for fewer process steps, is also popular in many PMIC designs. Other customizations like enhancing performance or trading off design features for smaller IP size are also possible since we have more engineering resources than our competitors. Customization is another way in which we broaden our product portfolio. Furthermore, automotive is the next huge driving force behind the semiconductor growth momentum. No matter internal combustion engine cars or electric vehicles, PMICs are in the various systems of almost every car. From powertrain to the cockpit, ADAS, and even autonomous driving, these power ICs must pass a number of automotive-grade certifications like AEC-Q100 and ISO 26262 to prove their ability to perform well under critical environment fluctuations while keeping humans operating these vehicles safely. We are proud that our OTP NTP IPs are reliable in many kinds of applications, with no exception to automotive electronics. Our existing products have passed AEC-Q100 to guarantee that our eNVM works well in high operating temperatures. For safety standards like ISO 26262, our NeoBit and NeoEE have been certified in 2019. NeoFuse and NeoNTP are now undergoing certification and are expected to obtain certification soon. We have many methods to ensure that the design of our IPs are reliable and safe. For example, optimizing the marginal design, testing methodology, error correction design, and quality analysis like FMEA, FTA, DFA, etc. are just some of the ways in which we ensure that our eNVM IPs are robust. Customers are welcome to inquire with our sales or customer engineers for more details. The next section, we are going to talk about our high-density eNVM solutions. As discussed in previous sections, for eNVM in smart PMICs, high density is a popular trend. In the early years, 256K bits and the 512K bits were already considered as high densities for embedded OTP and NTP memories. However, we've seen higher density demand for smart PMICs, and the SONOS Flash is our answer to the new trend. eMemory's SONOS Flash technology, NeoFlash, has been available for years, and we expect the demand to be growing. Compared to floating gate embedded memories, SONOS Flash has better scalability for process nodes like 28nm, which is much more advanced than the latest BCD process. It is also easier to implement NeoFlash than split-gate flash because it only requires 2 to 3 additional masks, thus leading to shorter cycle time, higher yield, and better cost structure. On the other hand, while MRAM and ReRAM are the rising star technologies and requires fewer masks as well, we expect MRAM and ReRAM to potentially be SRAM and external NOR flash replacement. Therefore, NeoFlash is at a sweet spot for smart power applications between 19nm to 40nm BCD processes and MCU products in 28nm logic platforms. It is an excellent alternative to existing embedded memory technologies. As mentioned in the previous slide, MRAM and ReRAM are the future of advanced non-volatile memories. eMemory is now working with third-party companies that provide MRAM and ReRAM cell technology. A brief list of ReRAM and MRAM design features is in the right side blocks. Our ReRAM supports up to 4 megabits on the 40nm ultra-low power platform. Is now available in a major foundry in Taiwan, and the 16 megabit product on the 22nm ultra-low leakage process is expected to be ready by the end of this year. In addition, 32 megabits MRAM is expected to be available in the first half of 2023. We anticipate MRAM ReRAM technologies to be able to further push the limit of eNVM density and operation speed boundaries, then create a new market for future applications. In summary, smart PMIC generally means better control of the power transmission activities, and of course it needs to be faster, safer, and more efficient. Embedded memories provide apparent values per power controller designs to put critical information inside the integrated chips. eMemory is our customer's leading eNVM provider with the broadest product portfolio and the most comprehensive foundry availability. We also have the most adequate resources to help our customers to customize and implement embedded memories in their designs promptly. Furthermore, we are dedicated to embedded memory technologies and have more experiences co-working with world-class foundries and fabless companies compared to our competitors. Our value has been proven for decades, and we are your best choice for eNVM IPs in the world. Thank you.
All right, we are now open for Q&A. If you have any questions, please use the Q&A box below to key in your questions. Okay, we have a few questions lining up. The first question is, how about the availability of NEO Flash?
Okay, the availability of NEO Flash is so far we have some 0.11 and 0.18 micrometer logic platforms, and some 0.18 and 0.16 high-V platforms with NEO Flash implemented. And we do now have some several 55 nanometer BCD platform projects are under discussion with major foundries. So we expect that the availability of NEO Flash will expand in the future.
Another question is, what is your recommended OTP memory type for 1 kbit in 40 nanometer TSMC?
I assume your question is for BCD platform, right? So we will suggest for 40 nanometer platforms, NeoFuse could be our recommendation.
The next question is, which fab has successfully qualified for eMemory's SONOS Flash?
If you are more interested in SONOS Flash, you can leave your message, and or we will provide our sales and customer engineer contact information to you.
The next question is, are eMemory's MRAM or ReRAM available on BCD nodes?
So far, our MRAM and ReRAM are mainly on ultra-low power and ultra-low leakage platforms targeting IoT applications. But we do expect they will be considered to be implemented on BCD platforms. And we are now discussing the feasibility with foundries right now.
The next question is, do you require process modification for process with record of NVM, MTP before? For example, if the gate structure is not suited for MTP.
Our NTP solution, for example, NeoEE and NeoNTP, is 100% logic compatible. So we don't have to do any process modification or any additional masks required. But what I mentioned in the slides that is for special cases to customize our IP for customers. And we can adjust many, for example, peripheral circuits to trade off some specs for our customers' requirements. Okay, so I hope this will answer your question. And if you need any more detailed discussion, I probably discuss with you after this webinar. Thank you for the question.
The next question is, what is the current status of your embedded flash for TSMC 90 nanometer process?
If you mean embedded flash, actually we have NTP, which is our new NTP solution on TSMC 90 nanometer process, BCD process. So new NTP is zero max adder, so 100% logic compatible. So if you are targeting higher density embedded flash, so maybe we can have a further discussion, and we will contact you and then to understand more about your requirement. Okay, thank you for your question.
The next question is, what is your overall advantage over FAB in-house eNVM offering?
To be honest, if you compare a specification between eMemory solution with fab offering, it depends. It varies in different fabs. So I may not answer this question so far, but one thing can be mentioned is design houses. If they encounter some capacity issues that they need to change their design into other fab, then eMemory can offer this flexibility for design houses to change fab. So, but if you're using the in-house solution of fab, then you can do this.
In the interest of time, we will close our session for today. Thank you for joining us today, and the replay of our webinar will be available soon on our YouTube channel. Thank you once again, and have a good day.